Hello friends, this is Alexey. The latest financial reports of the major companies in power semiconductor industry show positive growth, meaning further investment in technology. This is good news for power electronics market. And back to news, it is time to see what is new in power semiconductors industry. Two new dual-channel galvanic isolated gate drivers for IGBTs in silicon carbide MOSFETs from STMicroelectronics save space and ease circuit design in high-voltage power conversion and industrial applications. The new gate drivers leverage ST's latest galvanic isolation technology to provide 6 kV transient voltage capability in a wide-body package. The device can deliver a powerful gate control signal of up to 4 amps with dual output pins for extra flexibility in gate driving, allowing independent adjustment of turn-on and turn-off times. The active Miller clamp prevents gate spikes during fast commutation in half-bridge topologies. Circuit protection features include thermal protection, a watchdog for safe operation, and under-voltage lookout per channel to prevent starting up in a dangerous low-efficiency mode. Power Integrations, the leader in high-voltage integrated circuits for energy-efficient power conversion, announced the addition of two new 1700-volt rated ICs to its InnoSwitch 3 family. The new devices are the industry's first automotive qualified switch and power supply ICs to incorporate a silicon carbide primary switch and MOSFET. Delivering up to 70 Watt of output power, the new ICs are targeted for use in 600 and 800-volt battery and fuel cell electric passenger vehicles, as well as electric buses, trucks, and a wide range of industrial power applications. Highly integrated InnoSwitch ICs reduce the number of components required to implement a power supply by as much as 50%, saving significant circuit board space, enhancing system reliability, and mitigating component sourcing challenges. II-VI, a leader in wide bandgap semiconductors, announced that it has qualified its 1200-volt silicon carbide MOSFET platform on its high-quality silicon carbide substrates to stringent automotive standard requirements, and is expanding its relationship with General Electric by signing a 3-year technology access agreement with GE Research to gain access to the lab's world-class silicon carbide module technology and team of experts to accelerate customer design and engagement activities. A growing number of applications, such as electric vehicles, renewable energy, data centers, industrial motors, and power supplies, are driving the strong demand for silicon carbide-based power electronics due to their high efficiency, low total system-level cost of ownership, high reliability, and ability to achieve more compact system designs compared with state-of-the-art silicon-based devices. Leveraging its differentiated 150mm silicon carbide substrates, II-VI successfully completed the qualification of its 1200-volt silicon carbide MOSFET platform to the Automotive Electronics Council standard, exceeding it to 200 degrees Celsius. STMicroelectronics plans to double its investment this year up to $3.6 billion compared with $1.8 billion in 2021, buoyed by high demand that drove its earnings to beat expectations in the fourth quarter. That will include building the first production line of a new 300mm wafer plant in Agrate, Italy. The step up in spending stems from a global chip shortage that has hit manufacturers and fueled inflation for semiconductors, which range from low added value chips in washing machines to sophisticated sensors in cars and smartphones. STMicroelectronics, whose biggest clients include electric car maker Tesla and iPhone maker Apple, expects net revenues this year up to $15.3 billion, a 20% increase at the top of the range. Toshiba Electronic Devices and Storage Corporation announced that it will construct a new 300mm wafer fabrication facility for power semiconductors at its main discrete semiconductor production base, Kaga Toshiba Electronics Corporation, in Ishikawa Prefecture. Construction will take place in 2 phases, allowing the pace of investment to be optimized against market trends, with the production start of Phase 1 scheduled for within fiscal 2024. When Phase 1 reaches full capacity, Toshiba's power semiconductor production capacity will be 2.5 times that of fiscal 2021. The new fab will have a quake-absorbing structure, enhanced BCB systems, including dual power supply lines, and the latest energy-saving manufacturing equipment to reduce environmental burdens. It will also aim to achieve the goal of 100% reliance on renewable energy. Product quality and production efficiency will be improved by introducing artificial intelligence in automated wafer transportation systems. Going forward, Toshiba will expand its power semiconductor business and boost competitiveness by timely investments and research and development that will allow it to respond to fast-growing demand and to contribute to a low-energy society and carbon neutrality. Sales of electric vehicles are set to accelerate rapidly over the coming decade. With continuously improving batteries and consumers demanding quicker turnaround on charging, EVs design trends point to high power charging blocks. The emergence of wide bandgap semiconductors like silicon carbide allow better pairing of power devices with a fast charging application. This Wolfspeed's webinar will provide you with practical design considerations when selecting the topologies and power device with a focus on designing with discrete silicon carbide MOSFETs beyond 25 kW. That's all for today. Thanks everyone for your time. As usual, more power semiconductor news coming next week. Meanwhile, go to my blog Marketing Psycho for more information or get in touch with me in social media. See you next week. Stay safe.